Hello everyone, myself Sourin Ghanty. In this video, I will be describing about stack data structure. In the first slide, we have introduction of stack. A stack is a non-primitive linear data structure. A stack is an abstract data type that is popularly used in most of the programming languages. It is named stack because it has similar operations as real-world stacks, such as pack of cards or a pile of plates. It is an ordered list in which addition of new data item and deletion of already existing data items done from only one end, known as top of the stack. As all the deletion and insertion in a stack is done from the top of the stack, the last added element will be the first element to be removed from the stack. This is the reason why stack is known as LIFO data structure. In second slide, we have some common examples of stack. A common model of stack is plates in a marriage party. Fresh plates are pushed onto the top and popped off the top. Some of you may eat biscuits. If you assume only one side of the cover is open and the biscuits are taken off one by one from one side. Here you can see these examples in pictorial format. There are two types of stack implementation: static implementation and dynamic implementation. Static implementation uses array to create stack. Static implementation, though a very simple technique, but is not a flexible way of creation, as the size of the stack has to be declared during the program design. After that, the size cannot be varied. Moreover, static implementation is not too efficient with respect to memory utilization. And the second implementation is dynamic implementation. It is called as linked list implementation of stack. And there are several stack operations. First one is push operation. Adding an item onto the stack is known as push operation. If the stack is full, then it's said to be stack overflow condition. Algorithm for push operation. First, check if the stack is full or not. Second, if the stack is full, then it produces an error. This error is known as stack overflow. If the stack is not full, increments the top pointer to the next empty space. Add data element to the stack location where top is pointing. And fifth is return success. Second operation is pop operation. Removes an item from the stack. The item are popped is reserved in an order in which they are pushed. If the stack is empty, then it is to be said as underflow condition. Algorithm for pop operation. First one is first check if the stack is empty. If the stack is empty, then it produces error. If the stack is not empty, then access the topmost data element of stack and decrease the top pointer by value 1 and return that pop operation is succeeded. Third operation is size. The size operation is used to calculate the total size of the stack. Algorithm for size operation. First of all, we have to create a variable n with value 0. If the top is -1, then return n with value 0. That means stack is empty. If the top is greater than -1, assign n with top plus 1 and return n. And the next operation is full operation. It checks whether the stack is full or not. This operation is used to check the status of the stack with the help of top pointer. Algorithm for is full. Start. If the size of the stack is equal to the top position of the stack, then the stack is full. Return 1. Otherwise, we have to return 0. And end of the algorithm. Next operation is empty operation. Is empty operation verifies whether the stack is empty or not. This operation is used to check the status of the stack with the help of top pointer. Algorithm for is empty operation. If the stack top value, if the value of the stack top is -1, the stack is empty. Otherwise, the stack is not empty. Stack top operation. It returns the top element of the stack. These are the operations of stack. There are some complexities are described here. The push operation, pop operation, is full operation, is empty operation, size operation, top operation. All of these operations having complexity of order of 1. That means it doesn't require much time. There are several applications of stack. First one is infix to postfix or prefix conversion, redo undo features at many places like editor, Photoshop, forward and backward feature in web browser, used in many algorithms such as Tower of Hanoi, tree traverser, stock span problem, histogram problem. Backtracking is one of the algorithm design technique. Some of the example of backtracking are night tour problem, in queen problem, find your way through a maze, and a game like chess or checkers. In all these problems, we dive onto some way that if it is not efficient, then we come back to the previous state and go into the next another path. We get back from a current state and we need to store the previous state. For that purpose, we need a stack. Next one is graph algorithms such as topological sorting and strongly connected components. Another another application is in memory management. Any modern computer uses a stack as a primary management for the running purposes. Each program that is running in a computer system has its own memory allocations. String reversal is also an stack application. It is also another application of stack. Here one by one each character get inserted onto the stack so that the first character of the string is on the bottom of the stack and the last character of the string is on the top of the stack. After performing the pop operation on the stack, we get the string in reverse order. Stack also helps in implementing functions call in computers. Last called function is always completed is at first. Stack data structure has several advantages and disadvantages. The advantages of this data structure is as follows. It is very easy to create a stack. It does efficient data management. It has low hardware requirement. Anyone with access can edit this program. It doesn't get corrupted easily. It does efficient management of function. It has control and smart management of memory. And disadvantages of these data structures are it is not flexible, it lacks scalability, it is very difficult to copy paste, it has limited size of memory, random accessing of data is not possible in this data structure, it causes undesired termination and it has chances of stack overflow. Thank you so much. That's all for this presentation. Goodbye.